So, hi, Ondro. Last name is Michali. Is it pronounced right?
Yes, it is. It has two pronunciations. One is mine and one is Hungarian, but I'm not a Hungarian person, so I pronounce it in my language, and it's correct what you said. Is how I say it.
How you say it?
I say Mihaly.
Mihaly. Okay. Andrei Mihaly. Do you remember when you were there last time at AWS FM?
I think it was like 3 years ago.
Yeah, 2019, almost. Yeah, February of 2019, episode 26, with the title "Productive Clouds 2.0 with Serverless Jakarta EE."
I thought it was a longer time ago because then the COVID came. I thought it was before COVID, before COVID, but it was just before. And yeah, it was actually COVID came in 2020, right?
Yes, I think so.
3 years. Yes, it's almost 3 years.
So, and you listened to the episode 151 about modularization with Professor Matthias Juric, and you wrote on Twitter, you don't agree because even if you write Hello World applications, you always have at least one JPMS module, and you highly advise everyone learning Java starting with module first, right? This was your direct feedback.
Not really. The thing is, in my experience, modules are needed. They have their use case, but I haven't seen any tool that would make them easy to use. So I used OSGI for my diploma thesis a long time ago, and I found it quite interesting because it was possible to really implement two things in the application and then deploy one of them in one environment, deploy another one in another environment, but code them together in one project. At that time, I used it to build a UI in Eclipse, Eclipse SWT, I think. And they had an implementation in JavaScript too, with the same, or more or less the same API. So I used OSGI as an example how to create a modular application that can be deployed, can have basically two distributions on the same source code. And one of the distribution, the module that implemented the same API, same packages, but produced SWT UI, so standard desktop UI. And you could replace them to get a web application, basically, with JavaScript-based UI, just replacing modules without rebuilding anything, rewiring things. So that was interesting. And it was also OSGI supported something like an inheritance and extension points, so you could add more things into the application without rebuilding it. But that was a toy project for diploma thesis to just explore what's possible and how to build applications that adapt to different environments. But later, I found out that OSGI is not so easy to use because you had to learn a lot of XML and wire stuff together. And although there were tools to build this XML, it was not straightforward.
And there were some issues with class loading as well. What I have to say, I reviewed a lot of OSGI projects, but what they always did, they cheated. So in one point of time, they started, to expose everything. I think it's called to friend class load or something like this. So like the common space where all the modules can pick the classes. So okay, if you started with it, then forget about modules because
I see. That's one of the complicated things that I really didn't need in the project. I could run the application on the flat class path. I just wanted to benefit the modules during build time. So basically just assemble application from different modules and then just run it. No need to replace modules on the fly. It was an interesting feature if it worked.
Okay.
And I switched the connection. I think we can go on.
Yeah. So what you said, you were not interested in the hot replacing modules. You were more interested in build time optimizations, right?
Yes, and the modularity during build time and also development time. So it's also good to separate some parts of the code base to different modules. And that's what I really thought is an issue in later projects in Java, because in Java you basically have a flat class path. Everything that is public is accessible from any other package. And we started using Maven to kind of modularize our applications. But I quickly found out that it doesn't separate all the classes. So if you put all the modules together into one web application.
So you found out that Maven does not help you with class separation, right?
Yes. And it's not so obvious because at that time I thought that Maven just separates code. So it separates also, it separates the code which is written as source code. And somehow I thought that it also separates the modules, the binaries themselves. But it wasn't natural because I don't know why I thought that, because we were linking modules together. Some modules depending on some APIs in other modules. I just somehow assumed that we will use only the APIs that should be used, like the boundaries that according to your pattern, only the classes and boundaries. But at that time, we didn't use the BCE pattern. If we did, it was possible to also use classes in control and entities, the other modules. So nothing prevented us. And I saw issues with that because we had one big distinction between frontend and backend. And frontend basically didn't use transactions and only was used to build the UI. Backend was transactional using EJVs and should access entities. But then some colleagues started just using the code that was only intended to backend in frontend because they didn't realize it's only for backend. It was possible, perfectly easy to import it into frontend classes because it was on the class path. And then the code somehow lost its form and structure because we started to do things that should have been in transactional, should have been on backend. We started to do them in front end, and it was a mess.
Yeah, then I assumed it was a GSF project, right?
Yes, it was.
Yeah. So what we used back then in GSF projects, we had two packages, presentation and business. These were the top level packages, and within the business package we had the BCE structure, and within the presentation package we had different BCE structure. So it was fairly easy to see, how presentation accesses the business. But I see the issue in GSF, but even then, I would say, then I would have two modules, presentation and business, and no more.
Yeah, possibly. But if you want to separate some logic into two different modules, and also if you want to introduce, low coupling between modules,
okay.
Only the boundaries are accessed from other modules, you can only agree on some packages or some pattern, like you promote the BCE pattern so that only boundary classes should be used outside of the module, but you can't enforce it. You would have to use some code enforcer, like Maven plugin that scans the code and analyzes the packages and imports. But it's not supported by Java or any simple to use module system.
But actually, my BCE pattern is more permissive than you are saying. So what I am allowing is a boundary from one package could actually access control from other package. I mean, it is not nice, but I wouldn't see it as a defect. A boundary from one module, if it accesses the boundary from other module, then it's a little bit suspect because it looks like API calls API. So it's also strange. And boundary from one module, if possible, should not access directly entity from other module or packages or components. And control from one module can call control from other module, but if this relation becomes more and more tight, maybe it's time, to promote some logic from the one control to a boundary. So this is the idea behind. And what I'm believing more than strict modularization is having a nice small team with nice developers and then just be productive. Skip all the patterns, just think in business, implement the packages and go to speed. Just deliver the application. But the modularization happens on higher level. So if you would like to be completely decoupled, so what I would do, I would just ship another war. So I would have jars of wars, which are the actual modules, And within the war or jar, you could actually do whatever you like. So I would be less strict.
That's also possible, although it goes against the path we chose. We started with an ER and war inside it and other dependencies outside of the war packaged in the ER. And we wanted to simplify into one single war. If we had two wars, the deployment would be more complicated and would probably have to go back to ER, which contains several wars.
Which project was it? It's interesting that you are still working on such projects.
No, I'm not working on this anymore. It's history.
What was it like, roughly? What did it? Is it banking?
It was in an insurance company. Basically, it was an internal project, so not accessible to customers, but it aggregated data about customers, about the contracts with them across multiple countries, across multiple products. So the business people could, for example, compare which companies are valuable for the financial institution, which provides a lot of contracts with a lot of value, and also have relationships between mother and sister companies in different countries to allow them to understand how should they treat specific customers if they are big, what they can offer to them. For example, if they have insurance for a car fleet, but they don't have an insurance for property, then they could offer them these other products.
Interesting. So what I lost faith in OSGI and JPMS on server side if you don't have JSF, because usually you have the JAX-RS endpoint, and what usually happens, I have, let's say, on average 2 to let's say 10 top level packages or business components or modules, whatever you call it, with maybe per module or per boundary 1 to 2 JAX-RS resources, and this is already larger one, so you would get at least, I would say, 2 to 10 or 20 endpoints, and this would be, let's call it a service or microservice or whatever you like, and this would be a war. And the other wars then are absolutely forced to use the boundary, so there is no technical way to access the controls or entities directly. And the other day I was in the architecture workshop, and actually yesterday, and there was a small team of highly motivated developers. I know them for years, and they delivered actually a great application, a great microservice application. But I forgot they had roughly 10 to 15 microservices, and but there was actually pointless to have that many microservices. So we chatted, what is your release plan? Are you ever able to redeploy a single microservice? What's the benefit? Why you're doing this? And what we decided is to merge some microservices to larger monolith, and let them even communicate. So there was the question, should we use Kafka or not? And say, okay, what if this is complete anti-pattern, but I'm sure it will work in this project. Even use tables for communication is way simple. So we have some database tables, and all the microservices could access these tables. And I mean, this is anti-pattern, but I'm sure it will work in your context. And but if you look at the inside, the logical modularization, it's beautiful. So what I did, the package structure is the packages are named after business responsibilities. It is a very clear structure, and I would say this project is highly modular. But if you would look with a tool on it, you will find, a view wars or jars with, you could even, say this is a monolith. But it's an interesting story. So this is what I see. We need less and less modularization or packaging on the physical, layer. Like you don't need mainly OSGI framework, except you are building something like Payara. So if you're building a platform like a Payara server, I think this is a completely different story, because it is harder, to ship Payara as 20 independent services, which are 20 processes, So I mean, if you're building a platform like, let's say application server, CMS system, operating system, something like this, this is a completely different story. Then I think OSGI or JPMS provide incredible value, because the code base is larger, and you don't have the process isolation.
Yes, to some extent it's true. From like in real life, it's not that easy.
Yeah.
Even with Payara, sometimes I don't see the value of OSGI because it has to be adopted by every developer. And if developers don't think in modular ways, they can either shoot themselves in the foot with OSGI or just avoid using it, or use some workarounds like export all the packages, and then it doesn't really make sense to have a module. It only separates logically the classes, but all the classes are visible to other modules. So it needs to be carefully thought about, and if the developers don't know how to use modules, then it's maybe even less productive to use them, even with Payara or application service. But where I see modularity, how I would like it to be, is useful not only in application service, but in any multi-purpose library. Because a lot of libraries provide public APIs, but they also have internal classes. This is also true for application servers. Payara, for example, bundles Jersey or Weld from many components, which provide Jakarta E API. Mm-hmm. They also provide their own public API, and they also provide or include the non-private API, which is still public because it's public classes. So application can depend on these and can use them. And then I saw customers of Payara previously using Glassfish, and they relied on some proprietary features of Jersey or other components. And then Jersey got upgraded and a newer version of Payara, and they couldn't use this feature, or they had conflicts because they still had to bundle Jersey 1 in their application, but there was Jersey 2 present in Payara, so they had to use some class isolation features to get this working. Mm-hmm. And if there was an option to really isolate like public classes, which are not meant to be public outside of the application server or outside of the library, then we wouldn't have these conflicts in applications.
You are absolutely right. So I'm with you. So whatever I say public or my YouTube channel, whatever, it usually applies to projects. A project, I mean, how to call it, business projects. So we get hired to use, Payara, Quarkus, or whatever to deliver a applications to clients, and this is where my BCE ideas and so forth came from. And you are absolutely right. So a library, I see a lot of issues. For instance, what happened? I don't know actually why. Lots of developers in lots of projects they use, for instance, how it's called resource config, the internal Jersey resource config classes. Instead of the JAX-RS. So there's actually no added value. They use that, I don't know, for unknown reasons. And the problem is they started with it in Glassfish, and this was ComSan Jersey, I think, namespace. And then the JAX-RS, org. How it's called? Org, the recent one, the Jersey, they don't come with ComSan. There was org.
I think it's on the Glassfish.
Yeah, but it's all Glassfish something. So the namespace changed, but it was actually a bad idea in the first place to use this internal Jersey or Eclipse Link implementation in the first place. So you're absolutely right. This thing should be hidden from the developers, because it will be easier. Because what they did, they included one library, I forgot what, and they just used internal Payara libraries without any reasons. I asked them why, and no one knew the answer. So they had to find, I don't know, a tutorial or source code or whatever. And this was absolutely unnecessary. And if you would like to upgrade from old Glassfish to newest Payara, you have to think about that, for instance, right? And this would prevent some issues. And even JSONB recently, I wanted to use JSONB, and some libraries, ship provide the API and the implementations. The others, you have to include the API and the SPI. So it would be somehow nicer to have a clear separation between the API and impl. But having said that, for me, it would be a lot easier as application developer, just to pull the impl, and I would expect that the API comes with the impl. So for me, it is better to include one Maven module instead of two, but this is just convenience.
Yes, but even for implementations, there are classes that you don't want to expose to your users because you don't know if you will change them. Yeah. You don't want your users to break their applications if you change just a minor version of your library. So at that time, I saw a lot of people abusing the classes that were not intended for public use, and they used it because they were just available. I saw that with one of our customers. Fortunately, they are our customers, so then finally they came back to us and we provided them a better option. But first they tried to use an internal class in Payara server because the way how we expose it using the API wasn't enough for them. They needed to do something more dynamic. At first, just relied on the class, and it wasn't even available for compilation, so they used reflection to get that class from the class path and use it. But this was only research. Fortunately, they didn't go into
what they did with the class.
with this.
Which class was it?
It was for if the customer listens.
Okay.
But it was one of the, I won't be into detail, but it was one of the internal APIs that we provide around security.
Okay.
And we provide the functionality using basically annotations, with annotations, and then you configure the security and they wanted to have different providers, so they had to have various configurations depending on some context, and this wasn't possible with the annotation. It was just configured once. So they wanted to instantiate the implementation a couple of times.
Yeah,
it as an authentication mechanism.
So let's JPMS, for instance, Java Platform Module System, or Jigsaw, to the earlier. So I think I wanted to use that a couple of times, but not in microservice space or in my usual projects. Rather than I built a couple of command line interface tools with Java. And if you build such tools, you could actually have like a plugin system where you say, okay, I implemented one CLI tool and then have different modules which provide different functionality. For such a thing, JPMS is actually great. Before I invent something by myself, I could use that. The other example was a great example, and I forgot the name of the guy, but he won a Duke Choice Award, and they created with NetBeans and satellite tracking system. And this is one of the NetBeans, how it's called, Dream Team, I think. And the conversation was in Java 1, like he said, okay, they use heavily, NetBeans module system. And I say, okay, why you need a NetBeans modules in an app? And I said, okay, what they do, they get the satellite data, the signals, and they are processing them. And the processors or the plugins are implemented by external parties, so they can easily plug in the external functionality. Such a thing, which now with JPMS would be a great success story, because you could say, okay, this is our interface, implement this, and then we plug your functionality to our system. So something like a Photoshop, an extensible system, Visual Studio Code or something, this would be hugely benefit from plugins. This is, the natural way to go. But this is what usually not happens in business projects. So in I would say this is very, very exceptional use case that you have such requirements.
Yes, I agree that modules make more sense if you have different teams working together, so that you can really establish a contract with code. And in modular applications like NetBeans or Eclipse, where other people can write plugins and expect that things will work if they use the public API. If everything on a flat class path, then you still can get these issues that the plugin creators could use some classes that are intended for internal use, and then the plugin will break with a new version. Okay. So it's good to have separated modules and the API, and the rest not even visible or not even accessible. And I like that JPMS enforces this. So it's not only available during compile time, but even using reflection until you create some exceptions. You can't access the classes in other modules which are not intended to be.
That was a huge benefit of JPMS over OSGI, because for OSGI was more or less a class loader trick, but JPMS far deeper integration.
Yes, that's much better than OSGI. What is still missing in JPMS is versioning, which OSGI provides. So can mix in with OSGI. You can mix two different modules, which provide the same API but different versions, and you can wire them with two other modules, which GPMs doesn't provide now. If one module exports one package, there can be only one module that does that. Another thing is what I like JPMs, but what I don't like about it, it's invented like a lot of new stuff like module paths. We already have class path, and they introduced module path, and I still don't get why we need to have this separate module path. Why it can't be its own the class path, and the JVM would just scan the class path and create modules out of the class path. Maybe it's because of backwards compatibility. I don't know, but it certainly complicates things.
I think so. That they want to know to have a class path behave like it behaves, and they wanted to experiment with something new, and the module path was the obvious choice. So actually, are you using right now the BCE pattern inside Payara in development, or not at all? So the naming.
I don't think so. In Payara, every module is on its own. I don't even think that there's much to put into entity because there's
exactly.
not much state.
Yeah.
And I think the packages roughly separate the boundaries and controls, but I don't think that we talk about it anymore.
And what are you doing now at Payara? So what's your task, if you can talk about? So what's the new exciting stuff you are working on?
What I'm working on is I was involved for a couple past months. I was involved in these security extensions that we had for OpenID, for OAuth. They are basically just extensions on the top of the standard security API.
And Payara for so what's the story? So there are some mandatory JSON Web Token scopes in MicroProfile. And Payara was very strict about that. So if they were not available, Payara just ignored them or ignored the JSON Web Token. So is it now configurable? You know that? So can I say no? Even the mandatory JSON Web Tokens are not that mandatory anymore.
Not sure about that. I think we improved that, but there are still some issues. I remember that we had a question from a customer about ADFS, which is Active Directory Federation Service, I think, from Microsoft, which should be an OpenID Connect provider. But this is about providing GWT tokens, not using them for authentication. And it's not compatible with what Payara expects.
Okay.
Because I think it doesn't provide some mapping, or it provides some that are.
So you're working on the security modules. So you're just writing a lot of new stuff, or you just
Not much, because I'm not really doing development officially in Payara. Most of my work is supporting customers.
Okay.
That's why I'm closely in touch with customers. When they need something, I talk to engineers how to do that. And sometimes when I'm experienced in that area of code, because I'm also a developer, I help the team to get that done. But I always collaborate with other people. I'm not just doing these security connectors myself. I was just adding some features there, but most of it is developed by the development team. I know that you had Patrick working on Payara Cloud, so he's part of the development team, and he also did a lot of these connectors because they needed these connectors in Payara Cloud to provide authentication with different providers.
Are you also working with Payara Cloud, or?
Not really.
You should.
I'm just following what's going on.
Interesting project. Okay.
Yes, it is. I was in the beginning, even before it started. I was involved in discussions, in internal discussions about Payara Cloud. Started like 3-4 years ago. Almost in like 1 or 2 years after I was in the company, and I joined the company 1 year late after Payara was launched in 2014.
Okay.
2015. So I'm almost since the beginning as Payara started, and very soon we were thinking about providing something in the clouds. It just wasn't clear how it should work, but I always envisioned a simple service where you just drop a WAR file, provide the necessary configuration, and it just runs, and it can be scaled automatically. So then it took us quite a long time to find a good technology. And Kubernetes was not so widespread, and we didn't have so good knowledge about Kubernetes back then. So we started with lots of different cloud technologies, and some of them went nowhere. And then we hired Patrick and one other engineer to dedicate full time on this, and finally things changed, and we have a product that is close to the launch.
Yeah. And for the listeners, what it is, you can upload a war to Payara, and Payara starts and stops, or actually fully manages Kubernetes cluster, so you don't have to bother about Kubernetes. And the wars are started on Payara Micros, and they are managed by Payara cluster. So the Payara cluster is actually a Kubernetes cluster, and you can very easily add DNS, also domain names, and you get monitoring. So it is the serverless server, I would say. This is how J2E
yes.
was supposed to be at the
beginning.
The
idea is to make it as simple as to deploy AWS Lambda. Like you write code and you deploy it, and maybe it's simpler. But you have to build the code before. You have to build the war. So
but Lambda, it is simpler because in Lambda, it's not enough, to build a code. In Lambda, you will have to build in enterprise environment a VPC, then probably if you would like to have a JAX-RS endpoint and API gateway, and you would use for that Terraform or CDK, and then you can start with the Lambda implementation. And if you would like to access, let's say, an DynamoDB and Amazon, so you have to include the SDK. So I would say it is, if you know a little bit Java E, it is a lot simpler than Lambda. And and if you know both, I would say create Lambda from scratch and ship it. It will take you probably at least half an hour, if not 2 hours. And to ship Payara Cloud application, I would say 5 minutes. Because you only need a war. I mean, in the war, we did it quickly.
The idea was, when you have a war, you're basically done.
Yeah.
And you just create a project and deploy it. Then wait a couple of minutes until all the resources are ready. And you have an application running on some domain.
And a couple of minutes, I would say, is closer to 1 minute, because I even did it on stage in one conference, and it was quite fast. So a small war is...
We are improving it all the time. We want to get it as short as time as possible. And compared to how long it takes to create a Kubernetes cluster in Azure or Amazon, I think it's much shorter.
Yeah, the problem with Kubernetes deployment is what you have to do is to get the timing right, because the health checks. So it's really if you set the period, let's say 10 seconds, and your application the first time starts after 11 seconds, so you will have to start to wait 10 seconds again until the Kubernetes say you are ready. But if you set it to 1 second and you have 3 retries and the application starts 4 seconds, then it will never ready. So it is just quite an experiment to do it right, because what happens was, to me, I deployed, this was Payara applications, which started Payara full on my machine like 3 to 5 seconds, I would say. And it could be right. Yeah. And on Kubernetes, 3 minutes. And I said, this is mission impossible. I mean, what's going on? And the how it's called, the readiness probes were completely misconfigured, and it took longer, to download the Docker image. So this was what took so long. But everyone complained about, Java E is bloated or whatever. I was like, what's he talking about? It starts in 5 seconds or 10 seconds on my machine. It was very quick. And the problem were the readiness and how it's called, liveness, readiness and liveness probes. So readiness are the readiness are the problem, because if readiness is not successful, Kubernetes won't route traffic to this service, and it will wait. And this is usually what causes the delays.
But from my experience, I used Elastic Beanstalk, which is also based on Docker, and it's a simplistic setup. It's more close. It's quite close to Payara Cloud, except it's a general for Docker. Yep. So you deploy Docker images, and it does everything for you. But even that, when I redeployed the application, I had to redeploy or recreate a whole environment. So a simple deployment took 2 or 3 minutes. But well, if it was just redeploying the war, it would be a couple of seconds.
Actually, Payara Cloud should be faster because what you already have, you have the entire network established and all the pods are ready to use. If you redeploy Elastic Beanstalk, what has to happen, it really depends whether it's publicly available or not. You will have to create the VPC, or no, not you, Beanstalk will have to create the VPC subnets and the possibly even nets and all the gateways. And for instance, the creation of a single net gateway can take a minute. So if you're recreating the entire network infrastructure of your cloud provider, this alone can take 2 to 3 minutes. Just the Terraform script.
Yeah.
And if you have it in place with Payara Cloud, and you have to, so there is a huge advantage. So the deployment should be a lot faster than anything else, which involves infrastructure as code.
And we also have improvements in how fast Payara starts in the Docker container with class data sharing to pre-build an image for this class data sharing for the JDK.
Oh, is it to get advantage of this? Will I have to use the official Payara Docker image, or is it a general improvement?
I'm not sure if it's in the official Docker image. It's I think it's in the Docker image that is used in Payara Cloud.
Okay.
I'm not sure if we use it in our image. Certainly, we needed to add some support in Payara Micro to generate, or not generate, the JDK generates all the meta files, but Payara Micro has an option that it stops right after it boots, so that it generates or loads all the classes that are necessary for your application, and then it stops. So you just launch this, and then relaunch the process with the metadata, and the second and any other subsequent launch uses the metadata to start faster. So that's some of the optimizations that we already have there, but that's about that's when you restart the process, or the Docker container when you need to recreate the environment. Another option to optimize the startup or redeployment time is, I don't think we use it yet, but we can just redeploy the application without restarting Payara Micro instances. So that's always possible. And even though Payara Micro doesn't really advocate for this or promote this, it doesn't have an easy to way to do this. With Payara Server, you can connect to the admin console and redeploy the application. Payara Micro has that functionality, and we actually use it in one of the RQLink connectors, which the basic RQLink connector starts Payara Micro for every test. Is deploy the application and stops Payara Micro. But we have a connector that just deploys a simple application on Payara Micro, which is called a deployer, and it provides a REST API and works like the admin console of Payara Server, and it using the internal API of Payara Micro to redeploy applications. Deploy the applications using this REST API provided by the other application, and then you just redeploy the applications for every test, and it's much faster.
Okay. So what else you find exciting with Payara? What is your one of the recent favorite features of Payara?
Certainly, still Payara Micro is my favorite thing in Payara. Although most of our users, I think, and customers still use Payara Server because they migrated from Glassfish. But I still think it's a nice thing, and it started long before there was Halida Quarkus, or even before Quarkus there was this Wildfly Swarm or the other Thorntail. They were similar, but they started to use the hollow jar approach after it was already in Payara, and after they found out about this from our micro profile in discussions. So they learned some things from Payara Micro to also our competitors, and now some of their products have some of these ideas that we introduced there. The thing we still miss is Payara can be compiled to native code using GraalVM. So that's one thing I would like to have, and hopefully we'll add it at least to some smaller distribution of Payara Micro. We'll see. I think it's planned, but not for this year, certainly, and probably not for next year, because we are also working on supporting Jakarta EE10 when it goes out. and now we're adding support for Java 17, get it as soon as possible. So modernizing everything to be compatible with all the most modern tools out there. And then I'm looking forward to working on some native support. I think the most likely way to get this is when Jakarta E creates how's that called, core profile, which is plans to support things like that. It was initiated by the Quarkus team, who support native compilation, and they want to be compatible with some Jakarta E profile, and that profile uses I think all of the Jakarta E specifications used by microprofile, except CDI, which CDI should have some core profile itself.
Yeah, so there's CDI Lite. CDI Lite, yeah, yes. This is where the Micronode team is working.
Because the Quarkus had issues with some features of CDI, mostly I think the extension points, which are too dynamic for them, and they can't pre-compile everything. So the CDI team is now working on separating the things that can be compiled natively from the other ones, and only those CDI Lite features will be part of the core profile. And then we plan to implement core profile and add native support, native compilation support.
It's actually great news. So because so if you take a look at the history, the recent history, it's like the Quarkus or Micronode and Quarkus, they got the idea to basically deploy at build time. So they run away with the idea. And the Payara server couldn't do that because it's too dynamic. But you get another great idea, the Payara Cloud. And what I like about both approaches, they are both absolute best practices, but they are opposite, right? So what Quarkus is doing and what you are doing are complete opposite approaches. But now with Jakarta E core profile, and if it will work on Payara Micro, we will get another highly compatible microprofile in Jakarta E runtime, which will be similarly optimized to Quarkus. I mean, it has to be, otherwise the GraalVM won't run, and it will have similar behavior to Quarkus, and maybe even Payara Cloud could benefit from that, having even faster startup times.
Yes, and also lower resource consumption.
Yeah,
because how I see it is with native compilation, it's up to the user. It's his responsibility to use this native compilation to reduce costs. If they run their own infrastructure and they build, they pay for it anyway, there's maybe no reason to build native images of their application. But if they deploy the cloud, or if they want to run on IoT devices which have limited resources, they should. That's one of the best options to compile to native codes or native binaries. But then with Payara Cloud, it's basically our job, because we are paying for the resources.
Yeah,
we are just invoicing our customers for some usage of those resources, and that can be hard because otherwise we wouldn't have customers. And if we want to increase our margin, our profits, we need to lower the resource consumption on our side. So that will be also interesting for us, I think.
Cool. So on Twitter, you pinged me that maybe you are interested in some, developers working for Payara, right?
Yes, right. We're growing our team because we want to also expand on what we are doing with Payara Cloud, and we also needed to, in the past, add some of our engineers to work on Payara Cloud. So we are shifting or restructuring our team, and we also want to focus on Payara platform to add all those features I said.
Which is exciting. So there's hot Java tech now combined with Payara and maybe all the clouds. So Azure and in future even AWS, right?
Yes, we're still quite small, but we're trying to be big or act big. To matter. We're already doing that with Jakarta E, where I think we're one of the major players, and also in microprofile, although that's where other companies excel more. And we try to be a cloud company and also
Why you say this? Because your microprofile implementation is pretty complete, right? And,
yes, it is. Yes, it is.
And you are one of the few who actually implemented everything from scratch, which is you and Tommy, I think, right?
That's true.
All the others, they are picking the small rye. So I would say
and
the opposite.
Tommy, I think we are much faster to implement newer stuff.
Yeah, exactly.
Yes.
So I would say I don't see that. I would say Payara and Tommy excels because they implement everything from scratch, and the others are contributing more as to small rye.
And we're not contributing so much or into the discussion of where
okay, this is what I see. Go. Okay. Implementation-wise, you are shining, but it's not like you're pushing the standard
that
forward.
We need more engineers to be more active in these projects. We only can afford to be active in Jakarta, and Jakarta is huge. It has like 20 active specifications and some more specifications which need to be addressed, although they are not so active. We don't have even that many engineers, so we can't have a different engineer for each specification.
But the message to listeners is if you would like to have an interesting job, ping Andre, right?
Sure. Let me know. We want to hire a few engineers by the end of the year. And there's a lot of interesting stuff to do in Payara.
Perfect. Where people can find you on the internet and apply for the job.
I'm on Twitter, Ondro O. My first name, and make his first 3 letters from my last name. And you can certainly approach me there. I follow Twitter a lot, so I'll get the message the fastest way to use Twitter. On Twitter, I also have a link to my blog where I have other contacts, which is ondro.ingenia.eu.
Okay, I will put it to the show notes.
But you can also ping Payara. It's Payara Fish. I think Payara_fish is the Twitter of the company.
Okay, perfect. I will do that. I will put it in the show notes. And I would like to invite you back, not in 3 years, more than in 1 year, and talk about, Jakarta Core or whatever progress you made with the new cloud-native Jakarta E.
Okay, I'm looking forward to it.
It was a nice, modularization conversation. Less controversial than I thought, because actually we don't disagree, right? I mean, this is
more or less yes. I thought that we disagree in that that there are some use cases. I think that there are still some use cases also for application developers.
Yeah, sure.
It's just the tools are not up to the needs of developers. They are not as simple to use for regular developer to use them.
But we should also agree, that Twitter is terrible medium to discuss such things. Yeah. So on Twitter, it would be a flame war between us, and if we talk to each other, not problem at all.
And so, maybe we just spend 1 hour and we would exchange just a few messages because it takes so much time to write on Twitter.
So the podcast is a huge time saver for me. This is true.
Yes.
Okay. Thank you. See you next time.
Thank you. It was a pleasure to talk with you.